Welcome to the Stormsurf video surf forecast for the week starting Sunday, October 5th. First, we take a look at the South Pacific Ocean. No activity of interest is going on and none is forecast. We'll put this into motion just so you can see for yourself. Little gale here, forecast off New Zealand, maybe 26 foot seas per second, but nothing other than that. A little bit of activity under Australia forecast, but it does not make it into the Southwest Pacific. There we are, we're through the loop, doing it again, nothing going on. So take whatever southern hemi swell that's in the water now, make the most of it, because it's pretty much over for the season. But if you look in the North Pacific Ocean, it's a whole different story. Multiple tropical systems and good, legitimate winter-type systems in play. Let's go through them. Hurricane Simon off of Baja has produced swell radiating towards Southern California. A new tropical system, Vong Fong, developing, poised to move towards Japan. What was almost a super typhoon, Fan Fong, south of Japan, and then our new system off of Kamchatka with 35-foot seas and forecast to build. Let's get into the details. First up, let's take a look at jet stream level winds. These winds help support the formation of storms and help direct their track when they do form. This is a nice early season setup, as you can see. 190 knot winds pushing off the Kuril Islands, falling into what appears to be a developing trough roughly on the date line, a little bit northwest of Hawaii there, and then continuing with 150 knot winds pushing up into central Canada. So this is a great situation right off the bat. We put this into motion. Notice these winds continue, helping to form a bit of a trough here into Monday. Again, 190 knot winds, but that trough sort of falls apart, but not in a bad way, because what happens behind it, we have 150 knot winds building on Tuesday, and they just start taking over the dateline area. Good solid area here, not a whole lot of a trough per se, but winds covering a good part of the North Pacific Ocean, and that only builds as we get into Thursday and Friday. Look at that, 130 plus knot winds with a pocket of about 160 knot winds here, stretching the entire width of the Pacific Ocean and displaced south down at 40 knots, down at 40 north, with no sign of any splits or anything. This is like typical weak El Nino, or at least a solid sort of winter pattern, and this the first week of October. We'll continue to put this into motion. So we're into Saturday now, and the pattern just holds. It starts weakening towards the end of the 7-day run, but still there's another trough forecast here. All this is very supportive of gale development if the right surface situations develop. Oh, and look at this. We hadn't seen the latest 18Z run of the model. Another patch of winds building now, a week and a half out. Not believable, but still, yet more evidence that we're in a good upper level jet stream pattern, and this very early in the season. All right, let's take a look at surface level winds, surface level pressure. Of course, Hurricane Simon here off Baja. Hurricane Vong Fong developing south of Japan. What was Super Typhoon Fan Fong south of Japan, and then here our new system, and this is where we're going to focus for right now. 45 knot winds developing off Kamchatka, embedded in a broader area of 35 knot fetch, all pushing well towards the islands and to a certain degree to the U.S. West Coast. We put this into motion. Here we go into Sunday evening. 50 knot winds. Officially that would make it a storm, okay, but then it quickly falls apart. But here's the really interesting thing here. We'll go back, watch this. This is Fan Fong over Japan. As we get into Monday, Tuesday, notice the one core here, another core here, and by Tuesday morning, boom, it's all assimilated into one system. Officially, whether one could declare this extratropical or not, it's hard to say, but for now we'll say extratropical gale developing, 45 knot winds on Tuesday, again aimed well at Hawaii and the U.S. West Coast. Put that into motion, 50 knot winds, so officially storm status. Moving over the dateline, and underneath the labels you can just barely see it, 55 knot winds. and then that, oh, there we go, it kind of fades out into Wednesday. But this is the interesting part. Then it just sort of sits and simmers here on Wednesday, and then continues its eastward trek into Thursday before fading out. But notice how much area of this low pressure system covers, and then you have yet this other tropical system, Bong Fong, supposedly simmering here south of Japan. We'll roll it out, see what happens. So Bong Fong is probably supposed to go up into the China Sea, but another system builds in behind that, coming, cold core low, and that's into about 180 hours out. Now, whether this will develop, who knows? Whether it will tap any of this energy, who knows? It would be best if they did merge somehow, but right now the models aren't suggesting it. But the other system earlier in the week looks great. Let's go take a look at the wave models. So here we go, current significant wave height charts for the North Pacific Ocean, and this is our high-res tool that we can show great circle paths with. We'll get right to it. This storm peaks out, Sunday night into Monday morning. Relative to Hawaii, that's about the 319 degree path is what we had previously charted out, aimed basically right down the Great Circle Pass to Hawaii. So they should get a good pulse of 17 or even 18 second period swell from this one. And relative to Northern California, notice it's sort of pushing more southeast than east, and this is the direction, here's the path it needs to get into Northern California. And it's pretty much too much south for Southern California and too much blockage. And even swell size relative to Northern California is expected to be minor, but something to watch nonetheless. We'll put this into motion, but here's the interesting part. Notice Fanfan over here off Japan. Here's our system. We'll roll this into motion. Here they go. They start merging, and then by about Tuesday night, there you go, 32-foot seas. And right off the bat, that's aimed well at Hawaii, about the 319 degree path yet again. And relative to Northern California, much better, about 292. And it's actually pushing flat to the east, so that it favors the Great Circle Paths into California. But because Hawaii is so close, if this were to occur, they should get a decent shot of swell too. Now watch this, it actually almost lifts northeast, and you're into, let's say midday Wednesday. Relative to Hawaii, not so much energy coming down the Great Circle Paths there, but relative to Northern California, there's the 296 degree path. That looks pretty good. And for that matter, the Pacific Northwest should fare well as well. And so let's continue with that, putting it into motion. So it sort of peters out a little bit here on Thursday, and then it rebuilds. And the interesting part here is it's not building particularly large, but it's moving closer, and the closer the better relative to the U.S. West Coast. And then it fades out. Then here's our next system. This is Bong Fong, supposedly, simmering south of Japan. And here we go. This suggests it just moves into the China Sea, and that's kind of the end of it. And we'll roll this out. Whoops, that was pretty much it. So, looks like there is some good and interesting early season potential, focused, we'll say, on Hawaii, just mainly because of their proximity, but swell for the entire basin in this area if everything plays out as forecast. That's good because the southern hemi is all but asleep, and so the focus, of course, at this time of year should be the North Pacific. And with development like this occurring, like basically the end of September, early October, this is a good jump start to the year. And this is not the first swell that we've had. So the point being, there's a bit of a pattern going on here. The early season seems to be relatively productive, and that is a good thing. Let's get into why that is occurring. First up, the Southern Oscillation Index. Difference in pressure between Darwin, Australia and Tahiti. Negative numbers represent the active phase of the Madden-Julian Oscillation, which supports storm development in the North Pacific in fall and winter months. Positive numbers is the inactive phase. The good thing about this is we've basically been on almost a 2-month run of negative numbers. That's sort of softening up now. We see little bits and pieces of positive numbers here, but that's again the daily calculation. The 30-day mean or running average is up some, minus 5.77. It was down to minus 10 here at one point, but still all this is representative of at least the weekly active phase of the MJO. And then here's the 90-day running average, negative coming up a little bit. For the one day, it's actually down a little, but all this says we're on the good side of the curve. When you're in negative numbers, that's good. When you're in positive, that's not good. That suggests the inactive phase of the MJO and La Nina. So we're going in the right direction, and it appears to be holding. We're in a pattern now. That's good news. Here's another way to look at it. The 30-day average over the past couple of years. This is January this year. We had a big negative push that created a massive Kelvin wave that pushed east and really sort of set the tone to break the pattern from basically years of positive SOI numbers. We had one little blip here in July where we thought El Nino was getting going, but it dissipated. But then starting January, the whole equation changed. It sort of bounced back, but then here we are. We're just in this continue sort of negative trend, and that's exactly where we want to be. So a good part of this year has already been spent in negative numbers, much more so than years past. And the last time we had any kind of an El Nino was 2009, 2010. I can't say that we're there yet, but we're going in the right direction. More evidence of that. Looking at wind anomalies. These are wind speed and direction differences than normal for this time of year in this location. So we're in the West Pacific. Here is Australia, and then the Philippines are here. Notice westerly anomalies. That is indicative of at least the active phase of the MJO. And the interesting part is these westerly anomalies have been going now for 2 weeks now. So that would pretty much qualify it as a westerly wind burst. We'll get into that in a minute. But these westerly winds, specifically in this area here between about 135 and about the date line, put a little box right there, and that is where Kelvin waves are generated only by slackening of trades or out and out westerly winds. That's what is happening now. This is feeding yet more warm water pushing towards the Galapagos Islands, exactly what we want to see. Also looking to the east, we see this light easterly anomaly pattern there, nothing unusual. It is the west area, the West Pacific, where Kelvin waves are generated, not here. This is almost immaterial. We go a week out, we see westerly, so again, Western Australia, Philippines, the westerly anomalies drift and start moving towards the date line, still supportive of Kelvin wave development, but then you get a little bit of easterly anomalies starting to build, or at least forecast to build, in the Philippines. Likely more backflow in relation to tropical activity here. Notice all these westerly anomalies here and up here, but they're too far to the north. They're north of 10 north. You really want your westerly anomalies to be about 5 degrees either side of the equator, so put a little box like right around there going out to about the date line, and that's where you want to see it. And then continuing in the east, weak easterly anomalies. Again, nothing of particular interest. Here's another way to look at what we just saw, but over time runs down this side, and then we have the East Pacific here, the West Pacific here, the East Pacific here. The oranges and reds are westerly anomalies, the blues are easterly anomalies. And notice this blob right here. Westerly anomalies started basically the 26th of September, 120 east. So our main, what we call the Kelvin wave generation area is about 130 east to about the date line, and that's right in this area. So westerly anomalies through current, so what's that? That's the 26th through the 5th and into maybe the 7th. So that's about 2 weeks. Not a huge westerly wind burst, but certainly a minimal westerly wind burst. That's good for creating Kelvin waves. Next, we take a look at outgoing long wave radiation forecasts. Though this is not the same as surface level winds, it gives you an idea of what's going on MJO-wise. If you see the yellows and oranges, that's the inactive phase of the MJO. If you saw blues, that's the active phase. Basically, what we're seeing is a dead neutral pattern per the statistical model. And then if we go down and look at the dynamic model, it shows the exact same thing. You go, well, what's that mean? It doesn't look impressive at all. It means nothing's going on. No, actually, it's very good, because what you'd see in a normal year would be alternating active phase, inactive phase, the cycle going back and forth, when you see absolutely nothing and it goes on for weeks and weeks and months, which basically is where we've been since the start of the year. There has been no inactive phases at all. There's been no active phases. What this suggests is El Nino. That's the hallmark of El Nino, or some early flavor of it is a suppressed Madden-Julian oscillation. And then this is the upper level model, same sort of deal. The greens represent areas of enhanced or potential for enhanced precipitation. The yellows suppress precipitation. This at the jet stream level. So this green area here working its way slowly to the east over time, and here's dates, you can see the dates here, suggest the active phase of the MJO working its way east, followed by the inactive phase, followed by yet another active phase out. We're into the 14th of November. The interesting part is this model's been hyping all sorts of inactive phases, and when it comes down to the time when they're supposed to form, they never form. So this model would be biased towards what we'd say is a normal weather pattern, but when you're in a flavor of El Nino pattern or a more active pattern, the model doesn't hold together well at all, and it overhypes everything. This, what we just saw, is probably a better depiction of reality. So we look at this and go, wow, it looks like things might fall apart a couple weeks out. Guaranteed, that isn't going to happen, and it's just going to be more of the same. Not a whole lot of anything from an MJO perspective. Next, we take a look at ocean surface temperature anomalies as of October 2nd. So the oranges, the yellows, these represent temperatures warmer than normal for this time of year at any location on the planet. The blues represent cooler than normal temperatures. And what we're really interested in is this area. They call it the Nino 3.4 region. It's really bound from about 120 to about 170 and just a couple of degrees either side of the equator. And what we notice is generally warmer than normal temperatures. Not a whole lot warm, maybe half a degree or so, and a lot warmer here in the Nino 1.2 region. And this is where, for the most part, Kelvin waves collide. They hit land here. So they're generated in this area. They travel under the ocean surface, then gurgle up over the Galapagos. You get this warm pull here, and then the trades, or even suppressed trades, just a generally easterly flow pushes that warm water and drags it out into this area. Now what we see here is nothing that we would call an El Nino, but it certainly is nowhere near anything like a La Nina with cooler than water temperatures. So there's this general warming pattern in the atmosphere, and what that does, that tends to enhance the jet stream, and we saw that earlier. Clearly the jet stream is enhanced, and we suspect it is being fed by these warmer temperatures here. That sort of helps fuel the tropics. That pushes warm, moist air up here. Notice all the tropical storms that have happened here, and in fact off of Baja. Southern California's had piles of tropical southern but tropical induced south swells this year. We haven't seen that in a long time. Even Hawaii had a pretty good little scare about midsummer, but now the focus is clearly over here. That's exactly where you'd want it, and normal for a flavor of El Nino year. Typical tropical systems traveling east to west, and then they start recurving. Instead of just going inland and dissipating, what happens is the jet catches them because they are actually, the jets displace south, grabs them, and then they recurve to the northeast and then blow up in this region, creating swell. That's exactly what is forecast over the next coming days. So anyway, generally warmer than normal pattern, very much warmer over the whole North Pacific. This is no different than what we've been seeing for weeks or months now. So clearly we believe at this point in time all this warming in the tropics is starting to impact the upper level atmosphere and starting to affect the jet, and likely to help feed a better than normal storm track for this coming fall and winter. And the evidence at this point in time is already suggesting that is in fact the case. Here's another way to look at surface level water temperatures, sort of zoomed in. This is absolute water temperatures, absolute wind speeds. So the trades are still in effect, but notice this, actual hard westerly winds in one little spot here, but this is right where it needs to be, right in the heart of the Kelvin wave generation area. These are anomalies, differences from normal, and notice the anomalies are all westerly anomalies here. That's feeding Kelvin wave development. We'll get into that in a minute. Notice water temperatures, 1 degree or warmer in this area, 1 degree or warmer in this area. Here's your 0 degree dead neutral. So this whole area here is 0 to a half a degree. If you were having a real El Nino, and this is the Nino 3.4 region, you'd expect to see at least half a degree anomalies over here, and we're not seeing that, but we're not too far off the mark. But that really doesn't matter as far as a legitimate NOAA classified El Nino. What we're looking for is just this general warming pattern to do exactly what you're seeing happening. Enhance the jet, enhance the tropics, do all those sorts of things, because that's what generates surf. It may not generate snow, it may not generate rain, but it certainly would suggest that the odds are more in favor of a normal rain year and a normal snow year, at least relative to California. Anyway, in regards to westerly winds, so this chart, West Pacific here, East Pacific here, and what we're doing is looking at depth. These are anomalies. We'll look here. Here's actual water temperatures at depth across the equator in the Pacific, west to east, but it's the anomalies that are interesting here. Notice there's this channel of 1 degree anomalies that go down about 150 meters, and it starts where? Right where the westerly winds are, about 160 east. So the westerly winds blow here. They push warm water at depth down into this channel, and then notice this, a pocket of 2 degree anomalies here, 2 degree anomalies here, 3 degree anomalies here. So this is actually a Kelvin wave that was generated a couple months ago, starting to work its way into the Galapagos, and yet another Kelvin wave, or what appears to be a Kelvin wave, developing behind it, and probably yet another behind that. So again, it's 3 months for warm water to get from here to here, so we're already into October. So it'll be January before the warm water here shows up in the Galapagos area, which means we're pretty comfortable that the slight and gentle warming that's been occurring at the surface is going to continue all winter long. Again, feeding the jet stream, getting some momentum going, and that's exactly what we want. Not this a storm and then a stop and a storm. You want a kind of a consistent pattern. Let the storms get some rhythm going, get some traction on the ocean's surface, keep the surface basically churned up a bit so that when storms do push off Kamchatka or the Kuril Islands, that they've already got something to grab onto and there's good traction. That helps really just generate swell after swell after swell. It's been a long time since we've seen this sort of a pattern. Even the 2009-2010 El Nino was sort of a one-off, and we had gone through a long spurt prior to that. But now this looks, at least at first glance, like something a little bit stronger is going to develop. Here's yet another view, sort of a higher fidelity view. The models sort of drive some of this stuff, though there are buoys and all that, and sensors actually measuring the water temperatures. But here again you see Kelvin wave about ready to hit the Galapagos area, another large pool of warm water, and yet more warm water feeding down into it. Here's the path down here and then up this way to the Galapagos. So basically confirming what we saw prior. And finally, latest JASON-2 satellite data, sea surface heights. These are when the sea surface bulges a little. We're talking only 5 centimeters, but notice this. Where's the scale? Oh, it just doesn't show it. 10 centimeters in places. That suggests warm water at depth. It's the warm water that expands and pushes the surface of the ocean up just a little bit, but the very precise measurements. So this suggests Kelvin wave here, working its way in. Another area of Kelvin wave probably building here, and really the only area that we're most concerned with is here, the warm water at depth here. So that's our focus. And yet one more way to look at this, upper ocean heat anomalies. This is in the upper 300 meters of the ocean, and going back in time, October, Kelvin wave. You can see it. Anything that's the yellow oranges, that's warmer than normal temperatures. Kelvin wave in October of last year, that sort of started it off. There was actually one prior to that, small one. The huge one, January, February, March, that slammed into the Galapagos. the upwelling phases in between. Here's the next Kelvin wave that's in flight over time. So here we are, we're into October. It's working its way into the Galapagos. Not quite gotten there yet, but yet here is another pocket building that makes us believe yet a second Kelvin wave is being developed and is going to start making its way across the Pacific. All this is very good news. It suggests that this gentle warming pattern is going to continue at least through this winter. And finally, the chart that is most interesting, the forecast from the CVS version 2 model. So here we are, October. It's suggesting half a degree anomalies, let's say. And here's the projection. Now, of course, everyone knows you don't believe a model, let's say 3 to 4 days out, much less 3 to 4 months. But this model is specialized at long-term projections for ocean surface temperatures anomalies in the Nino 3.4 region. The interesting part about this model, and we've talked about this last week, is notice temperatures are supposed to go up to about 1 degree above normal in January. It was actually suggesting that it would do this back in maybe November, but sort of pushed it out a little bit. But here's the interesting part. If this were El Nino, you'd get your spike here, and then you'd see water temperatures really starting to drop off come April or May or even June. But no. They are forecast to basically flatline and continue. If you go into June and July, so this is the spring unpredictability barrier right in here. But if you're going into July, let's say, with 1 degree anomalies, and you've had an entire winter of warm anomalies, and the jet stream's already reconfigured, which it appears to be right now, already favoring storm development, and you go through another whole summer of warm water, then the winter following that would likely be a legit El Nino. So what we're sort of calling right now is this thing what we call a Modoki El Nino. It's not really an El Nino. It's just kind of a sort of a hint of an El Nino. It's moving that way. It helps build momentum in the atmosphere. What would be great is if we had a couple of years of Modoki El Ninos culminating in a real El Nino, because typically what happens, once you get your big El Nino, then you have your big crash afterwards and you fall right into La Nina. So we're not very interested in seeing any kind of a big El Nino anytime soon. A couple of years of Modoki El Ninos would be just fine. It would reconfigure the atmosphere. We'd have a couple of years of great surf. And the other interesting part is if you can get through the winter months in the North Pacific with a good storm track, typically this sort of Modoki El Nino thing will then also enhance the jet stream in the southern hemisphere for the following summer, which means you would have this winter, next summer, and then yet again perhaps another winter after that. Of course, none of this is believable at this early date, but this is what the tea leaves sort of suggest at this point in time. So, this is looking pretty good. We've covered a lot of territory. We've tried to do it pretty quick, so let's put a bow on this. First off, lots of tropical activity still occurring, focuses on the West Pacific, focused or driven by what we think is some lightly guiding active phase of the MJO, pushing towards some sort of weak flavor of El Nino. Storm currently pushing off Kamchatka, forecast to create a decent-sized swell starting about midweek in the middle of the North Pacific Ocean, radiating towards Hawaii and the U.S. West Coast. All that is still to be seen, but if it were to occur, it would be somewhat significant because it would be a tropically enhanced storm. So, swell looks like it's on the way. That's the good news. Long term, it looks like we're moving towards a Modoki El Nino at a minimum. Probably not a legit El Nino this year. That's fine with us. Let it keep rolling. Things are looking good. It seems like we've finally turned the corner on what has been a 3 or 4 year, effectively a drought in terms of surf and rain and all the good stuff that we generally look towards. So it looks like good times are ahead. So that's it for this week. Come join us. We'll do this again next week. Same time, same channel. In the meantime, go get some surf. Make the most of it. Pace yourself, though. We suspect there's a lot more to come. Thanks.